Hi, welcome to class. I'm Don Lafond, Professor Don, and this week in our Cisco 1 class, I am covering Module 11 IPv4 addressing. Now, I've made 4 videos. This is the 4th video. First video was an overview of IPv4 addressing and subnetting. The second video was in IPv4 addressing, a deep dive. The third video was in subnetting deep dive, and then this video is going to be a deep dive on variable length subnetting. So please make sure you've watched the previous videos before you watch this video so you get a basic understanding before we go deeper into variable length subnetting. If you're watching this video online, make sure let me go ahead and share my screen. If you're watching this video online on YouTube, please ask questions in the comment sections below the screen, and I will answer questions in a timely fashion. At least I'll try to. If you are watching this as a recording inside of our NetAcad classroom, then please ask questions inside of the help discussion forums, and I'll be very timely making sure I answer those questions. And let's go ahead and get started. Okay, so you should see my screen now. I've started recording. Let's go ahead and get going. So Module 11, IPv4 addressing, Part 3, Vlsm. We're finally getting to the module objective where we calculate IPv4 subnets for a /24 prefix, and specifically variable length subnetting. We're going to use the smallest subnets possible for a variety of network requirements, and we'll see that as we move through the presentation. So variable length subnet mask. So as we learned in the last presentation, it's easy to create multiple networks from one IP address that's given to you. In the example in front of you, we take 192.168.20 probably /0 network, and we subnet it using a /27, which gives us 8 subnets of 30 hosts. And you can easily apply those subnets to our network, and we end up with one extra /27 address. But as you can see here, we waste a lot of addresses. Sure, a /27 gives us 32 addresses, which are perfect for the 4 large networks. But these connecting networks here, the point-to-point WAN links, those connecting networks only need 2 hosts. They only need 4 IP addresses, the network, the 2 hosts, and then the broadcast address. So a /27 wastes 28 addresses per subnet. So you're wasting a lot of addresses. It's 84 in just those 3 networks alone. So applying a traditional subnetting scheme to this scenario is not very efficient and is wasteful. Variable length subnetting was developed to avoid wasting addresses by enabling us to subnet a subnet. So what that means is this is the traditional method where we break a network into multiple equal size networks. In this case, we have 8 /27 networks, each with 32 addresses, 30 host addresses. Now, in variable length subnet, we could take one of those networks and we can subdivide it. So in this case, we have 7 /27 networks with 32 addresses in each. And then we have 8 /30 networks with 4 addresses in each. And then we can apply those networks appropriately. So the 4 big networks get /27s, which give you enough hosts at net addresses, 32 in each, 30 usable. And then the connecting networks, we have only /30, so we don't have any wasted addresses now. We have 4 addresses in each network, the network IP, an IP for both of the routers, as you can see here, 25, 26, the network address of 2224, and then the broadcast address, which would be one more than the highest network, so it'd be 226. I'm sorry, 227 would be the broadcast, 28 the next network, 29, 30, broadcast would be 31, 32 is the next network, 33, you get the idea, right? So this is VLSM, and why we VLSM, because we didn't waste any addresses. Of course, this top network needed 25 hosts, we gave it 32, but you can't break down any smaller than the 128.64, 32, 16.8.4 that we've been learning all along. Those rules still apply. Now here they've written out the basics of VLSM. They've subnetted the one network that we're given, 192.168.20.0/24. We've broken it into 8 /27 networks by borrowing 3 bits. And then we take the last network and then we break it into 8 networks by borrowing 3 more bits to get to a /30. Now we have, in this case, we still have 7 networks of 32 bits, and then 32 IP addresses, and then we have 8 networks of 4 addresses. Hope that makes sense. It looks a little bit like this. The basic concept is you break down the networks smaller and smaller until you get the size you need. In this case, we maybe needed 64 hosts each for these 3 networks. And then we break that last one into 2 27s. Now we have 2 27s with 32-bit hosts. They don't have to be the same size as long as the addresses do not overlap. When creating subnets, it's easier to work from largest to smallest. So you take, let me go back a step, you take the requirements here and you put them in order. So 28 first, 20, 25, 20, 15, 4, 4, 4, 4, you write all those down, and then that's where you start when you start creating your networks. I've got some videos to show you to give you more details. This first video is the basics for VLSM.
The basics of VLSM, or variable length subnet masks, works like this. 1. Subnets do not have to be equal sizes, as long as their address ranges do not overlap. So we can create unequal sized subnets. They do not all have to be the same size. 2. When creating subnets, it is easier to work from larger to smaller subnets. So for example, I have the 192.168.1.0/24 network. I subnet the network into 4 subnets /26 subnet masks. So the subnets go up by 64. I now have 4 equal-sized subnets. With VLSM, or variable length subnet masks, I can decide that I want to change one of these subnets and further subdivide them into smaller subnets, as long as the address spaces that I create, or the subnets that I create, do not intrude into the other subnets. For instance, I could take this 192.168.1.192 subnet. The address range for this subnet goes from 192 all the way up to 255. What I can do is I can say, instead of having this subnet /26, what if I take that address space and divide it into 2 smaller subnets, size /27 each? If I do this, I effectively have created 5 subnets. The 3 subnets up here are 64 hosts each, and the 2 new subnets that I created from the 4th subnet are 32 hosts each. The reason I can do this is because my 2 smaller subnets do not intrude into the larger subnets. This is variable length subnet masks. In this situation, it has also allowed me to create 5 subnets, thus escaping the equal-sized subnet limitation of creating subnets in powers of 2. This gives me greater flexibility and allows me to create subnets of different sizes based on the requirements of my network.
So that's a basic concept. We will go deeper with an example. Before we get started in the example, remember, when you're breaking down your networks, make sure you list them largest to smallest. That's how you start. And then we'll just break those networks in half to fulfill the needs of the network requirements. In this case, the first network is 200, 150, 25, 10, and 4 network size 4 addresses. Let's go ahead and get that video going for you.
In this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets: one network for 200 hosts, one network for 100 hosts, one network for 50 hosts, one network for 25 hosts, one network for 10 hosts, and 4 point-to-point networks for 2 hosts each. Before I begin to create these subnets, I need to check to see if I even have enough addresses in this address space to create all of these subnets. So by writing out the network and the subnet mask in binary, we see that we have a /23 subnet mask. Here's 23 ones in binary. The last bit is in the twos place. If we look at this 8-bit grouping in the third octet, we see that the last one is in the twos place. That means the subnets would go up by 2. So the next subnet will be 172.16.2.0/23. So the address space that we're working with goes from 172.16.0.0 all the way up to 1.255. Let's see if this is enough addresses to create all of these subnets for this specified amount of hosts. I can see that starting from a /23 subnet mask, we have 9 host bits. So effectively, there's 512 hosts. If we look at each one of these subnets that we're going to need to create, I cannot create a 200 host subnet, but I can create a subnet for 256 hosts. That number does not reflect the usable hosts, but the total number of addresses in the subnet. Similarly, I'm unable to create exactly a 100 host subnet, but I can create a 128 host subnet, a 64 subnet, a 32 subnet, a 16 subnet, and 4 host subnets will satisfy these requirements. If I add up all of these numbers, 256, 128, 64, 32, 16, and 4 subnets of 4, the total number is 512. So I'll have exactly enough host addresses to create these sized subnets and meet the requirements. Once again, these numbers here for the subnet sizes that we'll create do not reflect the usable host addresses, but the total number of addresses in the host portion of the subnet ranges, including the network address and the broadcast address. So let's get started subnetting this network using VLSM, variable length subnet masks, and working from largest subnets to smallest subnets in order to create all of the subnets required. So working from largest to smallest, the first thing I need to do is to create a network for 256 hosts to satisfy the 200 host requirement. What I can do is I can subdivide this single network of 512 hosts into 2 smaller subnets of 256 hosts each. So instead of having a 172.16.0.0 network /23, I change the subnet mask to /24. This creates 2 networks, 0.0 and 1.0, each subnet having 256 or 8 host bits. Notice how the subnet mask has changed from /23 to /24, and I now have 2 256 host subnets. What I can now do is keep the first of these subnets and subdivide the second one. To do this, I simply take this 172.16.1.0/24 subnet and change it from /24 to /25. So now I have the 172.16.1.0/25 subnet. This creates another subnet, 172.16.1.128. Both subnets have a magic number of 128, meaning the networks go up by 128. So I've taken this one network of 256 hosts and subdivided it into two networks of 128 hosts each. Now I have a subnet to meet this second requirement. Moving on from there, I'll keep the first of these subnets and then further subdivide the second one. So now we no longer have the 1.0 network in its place. We have the 1.0 subnet and the 1.128 subnet. Then I subdivide the 128 subnet into two smaller subnets /26 each. So now there's no longer a 128 subnet. There's two subnets in its place, a 128 subnet and a 192 subnet. Both of these subnets have a /26 subnet mask. If I was to write this subnet mask in the binary conversion table here, we would see that in the fourth octet, /26 means that the last one in the subnet mask is in the 64's place, and the networks go up by 64. Furthermore, with the /26 subnet mask, you only have 1, 2, 3, 4, 5, 6 host bits, and 2 to the 6th power is 64, meaning there's 64 hosts, 62 usable per subnet. I now have my 256 host subnet, I have my 128 host subnet, and my 64 host subnet. I can subdivide the second of these two subnets into two smaller subnets of 32 hosts each. To do this, I take the 192 subnet and subdivide it by changing the subnet mask from /26 to /27, creating two subnets of 32 hosts each. So now I'm no longer using the 192 subnet /26, I'm using it as a 192/27 subnet and a 224/27 subnet. From here, I still need a subnet for 10 hosts. I can take the second of these two subnets for 32 hosts and subdivide them to two 16-host subnets. To do this, we take the 224/27 subnet, change the subnet mask from /27 to /28, and now I have two smaller subnets. From here, I take the second of these two 16-host subnets. I only need one. The second one I'll use for 4 subnets of 4 hosts each. So now instead of the 240/28 subnet, I have the 240/30, the 244/30, the 248/30, and the 252/30 subnets. Looking at the subnets that have been left, we have the 172.16.0.0/24 subnet. This is good for 256 hosts. We have the 172.16.1.0/25 subnet. This is good for 128 hosts. The 172.16.1.128 subnet /26 is good for 64 hosts. And the 192/27 subnet is good for 32 hosts. The 224/28 is a 16-host subnet. And then the last 4 subnets /30 each, 240, 244, 248, and 252, are good for 4 hosts each. Once again, these sizes do not reflect the usable hosts in each subnet, but the total number of addresses in the host portion. For usable host addresses, you need to -2 from each subnet. If we examine the host addresses closely, we'll see that none of the subnets overlap. In other words, this 172.16.0 subnet goes from 0 all the way up, since it's /24, to 255. You can see that the next subnet starts at 172.16.1.0, so the two subnets do not overlap. Similarly, this second subnet goes from 0 to 127, and we can see that from host 0 to 127, the next subnet at 172.16.1.128/26, that there's no overlap. This subnet ends at 127, the next subnet begins at 128, and so on and so forth. In the end, we've created 9 subnets of different sizes: a 256, a 128, a 64, a 32, a 16, and 4 host subnets. This is Vlsm, and it allows us to create subnets or networks specific to the needs of the network.
Okay, so that explains variable length subnetting, but when I went through the course many years ago, I couldn't quite visualize what they were talking about, what the teacher was talking about. It wasn't clear. The concept wasn't clear. So I went online and I searched videos, and I found this video to be extremely helpful to explain the concept of variable length subnetting. You would never want to do this in an actual exam. It would take way too long to do it. There's other ways, and I'll show you a method in a little bit by Jason Johnson, and build a table, and you can answer questions quickly and easily. But first, let's just make sure you understand the concept of variable length subnetting. So I'm going to go ahead and open up the link, and then I have to bring the page over to you. Of course, these links are still out on YouTube, and you can watch the video directly there if you like. The link was at the bottom.
Welcome to the Electronics Channel. I'm David Williams. In this video, I want to talk about variable length subnet masking. Now, this variable length subnet masking, or VLSM, is the process of splitting an IPv4 network into smaller networks, where the new networks are not all the same size. In this particular example we're looking at here, you can see we've got LAN 1 with 20 devices, we've got LAN 2 with 100 devices, we've got LAN 3 with 40 devices. We also have a LAN 4, which is going to have about 3 or 4 IP addresses on it. Now, if we started with a /24 network, or a network that has 256 IP addresses in it, we could split that up into 4 networks, and because we got 4 different networks here. However, if we split it into 4 equally sized networks, that would give us 64 IP addresses per network. LAN 2 requires 100 devices, so this would not work. Variable length subnet masking allows us to more optimally assign the number of IP addresses to meet the needs of each network. Now, a simple way to visualize the breakdown of a range of addresses is to use this box method. So this box currently represents a /24 block of network addresses. So in this /24 block, I have 256 IP addresses. So the way the box works is I have my starting address at the top corner of the block box and my ending address at the bottom corner of this box. So I've got this range of 0 to 255. Now, if I split this box in half, do one step of subnetting, this gives me 2 /25 networks, each with 128 IP addresses. First one ranges from 0 to 127. The second one ranges from 128 up to 255. And I'm going to keep doing this breakdown until I get to the smallest possible boxes I can have. And then I can use that box with lots of little tiny boxes in it to carve out the pieces that I need for each of my individual LANs. So the next step would be to break each one of these subnets in half to give me 4 /26 networks, each with 64 IP addresses. In this in half, and I have 0 to 63, 64 to 127, 128 up to 191, and 192 up to 255. Split these all in half again to give me a /27 network with 32 IP addresses in each network. So I get a range of 0 to 31, 32 to 63, 64 to 95, 96 to 127, 128 up to 159, 160 to 191, 192 up to 223, 224 up to 255. All right, now let's split all of these subnets in half again to give me a bunch of /28 networks, specifically 16 of these /28 networks, each one with 16 IP addresses in them. I'll split them in half again. I get /29 networks. Each network will have 8 devices in it, and there will be 32 total networks. The last split that's possible sets these all to /30 networks, each with 4 network addresses in it. But the first and the last one are not assignable to hosts, so you can actually only have 2 hosts in each one of these networks. And I draw the lines in to show the splits. But since I am kind of running out of space to draw numbers in, I'm just going to copy in a new typed out box. So here's my last split, which is a /30 with 4 hosts, 4 IP addresses per network. So you're now wondering, how am I going to use this box to help me create variable length subnet masks? Well, what you do is you would take your requirements for subnets, arrange them in order from largest to smallest, and then block off parts of the box here that would meet the requirements of each of your subnets. So let's look at an example. So I've got this network here that's created of 2 LANs with a given number of hosts, a WAN which just connects these 2 routers together, and I'm starting with a network 192.168.7.0/24. So if I put these in order of largest to smallest, I've got LAN 2, which has 60 hosts in it, LAN 1, which has 20 hosts in it, and the WAN, which only has 2. For 60 hosts, I'm going to need a network size of 64. For 20 hosts, I'm going to need a network size of 32. And for 2 hosts, I'm going to need the network size of 4, which is the smallest that I can have. So my block of 64 is going to be taken up by this block of 0 to 63. Then I'll take the next 32 addresses, which is going to be 64 to 95. And then the final block, which is only going to require a network size of 4 for the WAN, can be this block right here. So LAN 2 network address will be 192.168.7.0. We started with a /24. We cut it in half to give us a /25, cut it in half again to give us a /26, and have 64 devices. So this will be /26 network. The next network, the network address is 192.168.7. Well, it's the first address in that block, .64. This is cut in half from the LAN 2, so this will be a /27 network. And the last network is 192.168.7.96. And this is the smallest network we can have, which is a /30. So now I've got the networks defined for LAN 1, LAN 2, and my WAN, and I was able to do that in the most optimal fashion, not wasting any IP addresses. Now I have all of these blocks available to potentially assign to other networks in case I have need to expand my network in the future. Okay, here's another example with 3 LANs and 2 WANs, and you can see the different sizes of the LANs, and each one of these WANs is only going to need 2 addresses because these are just point-to-point connections between the networks. So first step, organize these subnets in order of size. So I have LAN 2, which is the biggest, requires 115 addresses. LAN 3 is the next biggest, it requires 40 addresses. And LAN 1 the smallest LAN with 25 addresses, and then I've got these two WANs connecting all these LANs together, WAN 1 and WAN 2, both with the size of 2 addresses. So what's the network size that I need for each one of these? To get 115 addresses, I will need to have the network size with 128. To get 40 addresses, I will need the size of 64. 25 addresses, I'll need the size of 32. And for 2 addresses, I'll need a network size of 4. So that first network of 128 is going to take up addresses 0 to 127. So there's my first big block. The second block will take up the next 64 addresses. So the next block of 64 addresses is right there. LAN 1 requires a block of 32 addresses. The next 32 addresses will be these ones here. And then the 2 WANs each need 4 addresses. So this will be for W1, and this block will be for W2. So there's the 5 networks that I need, and I've blocked it off so I can see the starting and ending address for each one, which tells me the network address and the broadcast and the last address for each one. LAN 2, its network address. Oh, well, let's say I forgot to designate what block I have for this. So let's say this is 192.168.77.0, and it's a /24 block. So the network address will be the first address in this LAN for LAN 2. So that'll be 192.168.77.0. It's half the size of the /24, so this is a /25 network. The next network, its first IP address is .128, so that will be the network address for this LAN 3, 192.168.77.128. It's half the size of the previous one, so this is a /26. LAN number 1 starts at 192, so that's the network address, 192.168.77.192. This is a slash. It's half the size of the previous one, so it'll be a /27 network. And then these will both be /30 networks. WAN 1 has a starting address of 192.168.77.224. That's the network address. This is a /30. And the last one, 192.168.77.228. And again, it's a /30. So this information here gives me all I need to know about my 5 networks. And now I can take that information and start configuring my networks. Okay, let's do one more example where I've got 4 LANs that are all connected to the same router, and these are all various sizes from 4 up to 41 hosts required. Well, of course, plus the IP address for the default gateway, which will be the address of the router. So really 5 IP addresses here, 21 here, 42 here, and 11 here. But that doesn't actually change anything because it doesn't go beyond the power of 2 boundaries. Okay, first step, let's put these in order of size. So I have L3 that has 41 devices. I have L2, which has 20 devices. I have L4, which has 10 devices, and L1, which has 4 devices. 41 devices, I need a network size of 64. For 20, I need 32. For 10, I need 16. And for 4 devices, I will need a network that supports 8 addresses. This first block of 64 will take this block right there. Second block is a block of 32, so I need the next 32 addresses for it. It's going to be this block right here. The third block requires 16 addresses. So the next 16 addresses will be 96 to 111. And then finally, I need a block of 8. So that's going to be addresses 112 to 119. So now I need to figure out the network address and the subnet mask for each one of these networks. This first one is going to be the first address. So that'll be a .0 address. Well, again, let's assume that I'm starting with the /24 network. So let's go 192.168.10.0/24. So the network address here will be 192.168.10.0/24. 192.0/26 for 64 host network. The next one starts at 64, so that'll be 192.168.10.64 for the network address, and this will be a /27 network. The next network starts at 96, so the network address is 192.168.10.96, and this is a /28 network. And the final one, first address is 112, 192.168.10.112, and this is a /29 network. So now I've got my network design down. Next thing to do will be to configure all the devices on this network. So this was variable length subnet masking, and I hope it's starting to make sense to you now. Thanks for watching. I'll see you in the next video.
Now, that video truly cemented in my brain how variable length subnetting work. Now, you would never want to draw out a chart like that under any circumstance. In fact, I've tried doing it in class just to show off that I could do it, and I got lost in the numbers halfway through. So you would never actually want to do it. You try it. It's not easy without cheating and looking at it already completed. Anyways, so it would be it would be long and cumbersome to do that on an exam. But Jason Johnson showed us on the next video. Jason Johnson shows us how to quickly and easily build a chart that I encourage you to draw out before you go into an exam, whether it's an exam in my class or in a class you're taking somewhere else, or ultimately in the CCNA exam. Just draw out this chart. It will help you quickly and easily answer many questions about subnetting and IPv4 addresses in general. And I actually use this chart myself. I've modified it slightly. It changed around a couple of the rows, but this is how I go into any exam. I just draw out the chart. It's done. That and my scale 2, 4, 8, 16, 32, 64 all the way up. I draw that out to the second octet. I don't always. I get up to about 56,000 addresses, and I start losing track. So I get one past the third octet in my 2 to the 1, 2 to the 2, 2 to the 4, 2 to the 3, 2 to the 4, etc. chart. Anyways, so let's watch this video, and hopefully you can take notes and have them handy when you're ready to go into any kind of exam. Here we go.
Okay, well, this video is going to be on subnetting, and I'm going to show you my way to do subnetting. There's a few different ways to do subnetting, but this is the way that I have found to be the easiest. So I'm going to make some assumptions that you already know about the basics of dotted decimal and decimal to binary conversion in this video that you've already got a handle on that. So we're going to use the dotted decimal number IPv4 address of 192.168.10.0/24. The 24 just means that our subnet mask of 255, and my handwriting is not the best in the world, so I apologize for that. So 255, I'll have to slow down here. I get moving really fast. So 255.255.255.0, that's our subnet mask, because we're using the first 24 bits in the subnet mask for our network. So this is our network, this is our host. So we know now, just by this IP address and this /24, we know that we have one subnet, and we have how many hosts per subnet? Well, we know that we're using the last octet. So we know that we have to use the 0. We have to use the 0 as our network ID, and we have to use the 255 as our broadcast ID, because our first IP address is 0, and that's our network. Our last IP address is our broadcast, and then so 1 to 254, and any number in between is our host. So that's that's our network ID, that's our broadcast ID, and these are our host IDs that we can pass out for this subnet. But let's say that you are told that you need to, and you're probably going to see questions like this. You're going to see, I need 2 subnets and I need 12 hosts on one subnet and 20 hosts on the other subnet. So how do you figure that out? And there's a lot of different ways to do it. And I'm going to erase some of this here. And I'm going to move this up here. Let's move this here. So I've got this, and let me erase. Tell you what, let me erase all of this here. So we go back here, and we're going to go 192.168.10/24 is going to be our IP address, and we're given the scenario. Let's say that we're given the scenario that we need 2 subnets, and we need 2 subs, and we need 12 hosts on one subnet, and we need 20 on the other subnet. Now, like I said, there's a lot of different ways to do this, but I have found the easiest way is to just write a little simple chart out. And my chart is this way. I just start over here on the right-hand side, and I write 1, 2, 4, 8, 16, 32, 64, 128. That's my 8-bit places. 1, 2, 3, 4, 5, 6, 7, 8. Some people like to draw the lines in there. I'm not good at drawing lines. I'm not good at drawing lines in. They make my hands hurt when I draw a lot of lines, but you can draw lines in there, and you can draw lines across this way. This works really well for when you go in for exams and you need to, before you start the exam, and you're usually given a whiteboard and you want to write out to do quick and easy subnetting. You can write this chart out at the beginning of the exam, and then you have it for reference. So we know that our subnet IDs are, at this point right now, we're at 255.255. Well, my pen keeps wanting to grab my screen and move around. There we go. 255. Let me erase this little bit right here. 255.255.0. Now, what we're going to do is we need to subnet this out, and we need to figure out how many hosts we need and how many subnets we're going to need. So if I write from left to right and do 1, 2, 4, 8 all the way up to 128, and then I start in the 8-bit place here, or the first place, and I write 2, 4, 8, 16, 32, 64, 128, and 256. Now, I know that when I look at this, if I'm borrowing my bit places, we're assuming that we're using 0.0.0. The first 3 octets are already used because we already have those turned on, but we're going to subnet into this last octet. We're going to borrow our bit places here. So what I do is I usually go ahead and make this a little bit more detailed, and I say this is my /24. I have already 24 turned on, so this is /25. This is /26. 27, 28, 29, 30, 31, and 32. So those are my last 8-bit places. You don't have to use the slash if you don't want to, because that just takes up extra space, but you could if you wanted to. And then I draw one more line above that, and these are going to be my mask numbers. These are my subnet masking numbers. So we know if I borrow 1 bit place, it's going to be 128 binary. So I know it's going to be 128. But if I borrow 2-bit places, it's going to be 128 plus 64. So if I do 128 plus 64, that's 192. And then the next bit place would be 192 plus 32. And so 192 plus 32 is 224, excuse me. So we do 224. And then 224 plus 16 is our next place. So we do plus 16, and then we get the 240. We get 240. So we're just using the powers of 2 in binary here. And then 240 plus 8 is 248. Then 248 plus 4 is 252. And then 252 plus 2 is 254. And then we have 255. Those are our subnet masking numbers. So if we borrow 1 bit place, our subnet for our last octet becomes 128. If we borrow 2 bit places, our subnet mask for our last octet becomes 192, and then 224, 240, 248, and so on. And so by writing this chart down, we have a quick and easy reference to be able to say what is our what is our bit places that we're borrowing? 25, 26, 27. What's our subnet mask when we borrow into that bit place? And then this next lines down here that we already wrote out, these are going to be how many subnets we get. This is going to be our number of subnets, number of subs, and this is going to be our number of hosts minus 2. So if we say we need 2 subnets, we need.
Okay, I'm just going to interrupt here a moment. I'm not sure where the best time to break is, but I just want to say I mentioned at the beginning of the video that I switched 2 rows. I actually switched these 2 rows because to me the /25 makes more sense. /25, 26, 27 makes sense on the top. And because I go 1, 2, 4, 8, 16, 32, 64, 128, 128, 192, 240, and then I come back in and I do 25, 26, 27, and at the bottom I do 2, 4, 8, 16. So I just switched these 2 at the top from my table. If you like it better this way, that's fine. It really doesn't make any difference. It just makes more sense to me to put the slash at the top and the subnet at the bottom. Of the 2, switch these 2 rows. I'm going to let him continue. I just wanted to throw that out there. I actually use this table when I don't have, just to speed up subnetting, than trying to work it through in my head and possibly making a mistake. So I find this table extremely useful. That's why I share with you. So I thank Jason Johnson for that. Let's go ahead and finish his video.
We need 2 subnets, and the first subnet needs 20 hosts, and the next subnet needs 12 hosts. We can look at our chart here and we can say, well, we know we've got to get 2 subnets out of borrowing 1 bit. We know that. But we're going to get 126 because remember, this is 128 minus 2. We're going to get 126 hosts out of this one. We're going to get 126 hosts out of here. We're going to get 62 hosts out of here, out of the 26-bit place. We're going to get 32 out of here, and we're going to get 16 out of here. So the rule of thumb is you make your subnets as you go ahead and break your subnets down as small as possible, or as many subnets as you can get, because we'll actually get 8 subnets. So we're going to get 8 subnets, but we only have to provide 2 of them for the exercise. So since we only have to provide 2 of them, let's scroll down here just a little bit here. So we're going to provide 2 subnets, but we would need to have at least 20 hosts in one and 12 in the other. Now we could break this into 2 subnets and we could have 126 hosts per. But let's just say that we want to leave a little bit of room for growth. So let's go on down here to the 8th, the 27th bit place here. We're going to borrow 3 bits over into the last octet, and that's going to give us 8 subnets, and 30 hosts per subnet. Well, we can't use the next one because that only gives us 16 places, and this is not VLSM. This is not variable length subnet mask. This is just simple subnetting. So don't worry about that yet. Now, what I do is I take my IP number that I started with, and my IP number, my network ID for this, because we know it's /24, we know our network number is actually 0. So we're going to come down here and we're going to write our first number out, and we're going to say that's 192.168.10.0. This is our first network ID on our first subnet. So what I'm going to do then is I know that my subnets are going to go in increments of 32 because my first IP address is a network ID, and we're going to go 30 increments of 32. So I'm just going to write down here, and I'm just going to assume that this is x.x.x 192.168.10. And you can draw lines if you want to. I could probably use an Excel chart, but I usually just draw little lines out here, and I just keep this simple. And I do 32, and then I go increments of 32. So 32 and 32 is 64. 64 and 32 is 4. That's 6, 6, 7, 8, 9. And then 96 plus 32, 128. We just keep drawing our lines out here. And I'm going to scroll down here just a little bit because we already have our top chart up there. And I'll leave it on the screen so you can copy that format if you need to. And then we have 128, and then another 32 is 8, 9, 10. And then 2, 3, 4, 5, 6, that's 160. And then I'm going to move my background here down just a hair. Okay, then we get the 160, and then we add 32 to that. So we get me draw my line here. I need to do 160 plus 32 is 2, 6, 7, 8, 9. That's 192. And then 4, and then 9, 10, 11, 12, and then 224, and then 4, 5, 6, and then 5, and then we end up with 256, which we know that is the end of our subnets. So we should have 8 subnets, because remember, we borrowed 3 bits, and that gave us 8 subs. So one sub, that's subnet. We can letter these A, B, C, D, E, F, G, H, or 1, 2, 3, 4, 5, 6, 7, 8. So we know I have those subs now. Now what I'm going to do is I'm going to go to a different color here, because I'm going to do my host range and my broadcast and we know this is my network. And so I'm going to do my network, my host range, and my broadcast in different colors here. So I'm just going to draw, this is my basic chart I'm drawing here. So we're going to do the next number. And now what I'm going to do is for my host range here, for my host range, I'm just going to increase by 1, because we know the next number up is my first number in my host range. So I just write a 1 there. I write a 33 there, 65 there, 97, 129, 161, 193, 225. And that's my last range. And then to get my last host number and my broadcast ID, I'm just going to turn on and say, let's turn on purple for this. And let's go for my broadcast ID over here. For my broadcast, I'm going to back off 1 number. So 32 minus 1 is 31. And then this one's going to be 63, because that's 1 less than 64. And then 95, 127, 159, 191, 223, 255, because 1 less than 256. And then when I and then I just back off 1 number from there. So that's 30, 62, 94, 126, 158, 190, 222, and 254. So now I've got my 8 subnets, and I know that my network IDs are right here for each one of these subnets. My host IDs are right here, and my broadcast IDs are out there. So these are each one of my subnets. Now, I have answered the question. I have at least 2 subnets, one with 12 hosts and one with 20 hosts, because I know that each one of these have 30 hosts in them. So then I can go give these out. And the question is, what is the network address of your first subnet? So, and I'm gonna use a second subnet on this, so I can just write this out. So my network ID for my first subnet is 192.168.10.32 slash. I'm going to do slash 20, and then remember we borrowed 3 bits, so we had 24 bits already, 25, 26, 27, so that's going to be a slash 27. And my next subnet is going to be 192.168.10.64 slash 27. So that when you do the subnetting, if I'm given the IP address of 192.168.10.64 slash 27, I'm going to know I can subnet this back out, and I can back into this chart, and I can say that 32 less than 64 is 32, because I can look at my chart up here and I can say a slash 27, I count by 32. So I can use this little handy chart here to go backwards or forwards. So I'm just going to leave this on the screen for a second just so you can see this. This is the chart I write out, and I know it looks sloppy, but I wanted to do it by handwriting, because that's how you're going to do before a test. And this is how I practice. I practice with a pencil and a pen and a piece of paper when I have some extra time. And I start the chart out, and I start at 1, double it up, 1, 2, 4, 8, 16, 32, 64. I go down 1 line and go back 2, 4, 8, 16. That's my number of subs, 16, 32, 64, 128, 256. On the next line, I show my bit value places, or my bit places, 25, 26, 27, 28. Then I write my subnet mask on there. So now if I was to say I need 2 subs, one with 12 and one with 20. So the first one is 192.168.10.32. If I was to write the subnet for that, or let's write the subnet mask for this .64, that would be that would be 255. We already know the first 3 octets are 255. So we would have 255, 255, 255. And all we have to do is look up at our chart now. So /27 we know is a 224. I don't have to do the math already because I've already done that. So that subnet mask is 224. So that's basic subnetting for the last octet. Now, for the third octet or the second octet, it gets a little bit more complicated, but it's really still using this chart. We're just adding numbers in both octets, and I'll have another video later on how to do that, how to subnet for the second or third octet, and this one is for the fourth octet. This is for your basic subnetting for a Network Plus exam, and I'm also going to have a video on how to do the ANDing, so how that you can tell how to see an IP address and tell which subnet it's in. And that's basically, we'll use some of this chart here in that as well. But this video was on basic subnetting. I hope this was helpful. Again, this is the chart here that you want to memorize how to write. And then you can take this chart and build your subnet chart out. And it comes in real handy on exams.
All right, great. Hopefully Jason Johnson's video here shows you a quick and easy way to subnet any or many subnetting questions on an exam. I love it. If they ask, in a /28, how many networks are there? Well, easy answer. In a /30, how many subnets can you have, right? Quick and easy, and it works flawlessly. As for this bottom chart, I don't know. I think he showed you that just to explain subnetting more so than to I expect you to write these out. Once you know the beginning network and the block size, right? We learned about block size earlier, the magic number giving you the block size, that you don't really necessarily need to write it out, but you could. Anyways, I thought this was helpful from my understanding when I went through Cisco 1 many years ago, and so I share it with you. Make sure you check out his website as well. And then, of course, once you have your addresses, then you have to go into the interfaces on your router. In this case, they're showing router 2, and they're showing the interfaces that go into, you have /24, in this network, 22.224, they assign 20.33 and 224. Wait a minute. 192.168, 20.33. No. They must start here. This is the 23 address, and then the serial interface for 22.26 is right here, and then 22.29 is right there. Easy enough to write those, create those interfaces. Don't forget, when you are creating your interfaces or bringing your interfaces up, go ahead and put a description in there. It definitely helps you, description, and then connection to the 32 network or connection to B, building B, whatever. It would help you to understand what you have written later when you're looking at it. All right, great. A little bit about structural design. So when we're talking about IP address network address allocation takes planning. IP network planning is crucial to developing a scalable solution to an enterprise network. To develop an IPv4 network-wide addressing scheme, you need to know how many subnets are needed, how many hosts each particular subnet requires, and what devices are part of the subnet. You also need to know what parts of your network use private addresses and which use public addresses, and many other determining factors as well. Floors of a building, for example, depending on how you are going to subnet. To design an IPv4 addressing scheme, examine the needs of an organizational network usage and how the subnets will be structured. Perform a network requirement study by looking at the entire network to determine how each area will be segmented. Then determine how many subnets are needed and how many hosts are needed per subnet, and then determine DHCP address pools and layer 2 VLAN pools, which we cover in different presentations. Then assign your addresses. So within a network, there are different types of devices that require addresses. End user clients, host devices such as PCs, most use DHCP to reduce errors and burden the network support staff. IPv6 clients can obtain address information using DHCP v6 or Slack. And in Slack, they actually create their own addresses. We'll learn about that next week. Servers and peripherals, these should have predictable static IP addresses. You don't want your printer's IP address to change. Otherwise, you'd have to reconfigure it on all of your devices. Servers that are accessible from the internet. Servers must have public IPv4 addresses, most often accessed using NAT. That we learned that in Cisco 2, I believe. Intermediary devices are assigned addresses for network management, monitoring, and security. We talked about that when we assigned a management IP to a switch to be able to telnet or SSH into it, right? And then gateway, of course. Your router and or firewall devices are gateways for the hosts in the network, and they must have an IP address, usually the first address or the last address, whatever your company decides. When developing an IP addressing scheme, it is generally recommended that you have a set pattern of how addresses are allocated to each type of devices. So if you use your first IP address on one router, you should use the first IP address on all the routers in your network. You're going to do a packet tracer, 11.9.3, Vlsm design and implementation practice, a packet tracer 11.10.1, design and implement a Vlsm addressing scheme. Really important to do this without using any kind of calculator, or you're going to be doing calculations in your head, but try doing it by drawing out that table that Jason E. Johnson showed us. Then create your addressing. It's critical to do it now when you're practicing to actually learn how to VLSM without any kind of calculator, because when you get to the CCNA exam, you're not going to have access to a calculator. Finally, you're going to do a lab 11.10.2, design and implement a VLSM addressing scheme, and that is the end of the third and final video for module 11. Let's go ahead and stop sharing. All right, great. So you're back to me again. So I spent a lot of time in module 11 creating these videos because it is absolutely the most challenging portion of our course. I lose sometimes a third of the class. They get to subnetting and then they can't get past it. In the past, I should say, they couldn't get past it. So I created these videos to help students fully understand what they're doing, how to subnet, what VLSM means, the concepts of VLSM, what it means conceptually, and then I even give you the Jason E. Johnson video to show you an easy and quick table to draw out to be able to answer questions quickly. Hopefully, these 4 videos, the 3 in-depth videos and the overall videos, hopefully they're worth your time. And by now, you're probably sick of subnetting already. That's okay. Get the homework done, get the assignments done. You'll understand the concepts, and you will be on to IPv6 next week. We will be on to IPv6 next week, and IPv6 is really easy compared to IPv4 subnetting. Anyways, again, my name is Don Lafond, Professor Don. It's been a pleasure teaching you how to subnet. If you have any questions, if you're watching on YouTube, please ask those questions down below in the comments. If you're in my class, ask questions in the help discussion forum. I also appreciate if you like and subscribe to my videos inside of YouTube. Really does help me to get more visibility to other students that my videos might be helpful for. So please give me that thumbs up and go ahead and subscribe, and you'll get notifications of my future videos. All right, Great. That's it for today's video. Thank you for coming, and have fun subnetting. You're going to have a blast. Everybody does.